Sir, it's not visible right now.
Okay. Now is it visible?
Yes, sir.
Okay, sure, sure. So, okay, good afternoon to all of you. And meanwhile, if you have any questions or if there is any problem in audio or screen, you can just unmute and just uh, ping me. Meanwhile, and also in between, if you have any doubts, you can just unmute and ask me. So, in this session, basically, we are going to discuss some of the popular use cases of the artificial intelligence, and I hope you have already gone through the basics of the AI and DL, that what basically machine learning, deep learning, and artificial intelligence is. So now we are ready to go with some of the popular applications. We are not going to the mathematical details right now at this moment. We will just go through the various applications because the motive of the session is that before going deep into generative AI and other kind of AI based applications and going deep into the transformers, encoders, and all the details, we should have some kind of thought process that what are the possible areas of applications which we can solve, which we can unfold using the deep learning, machine learning, and AI based techniques, so that meanwhile you can have just your mind working that yeah, we can also apply such kind of things in such kind of areas to make our research problems, to do some kind of future research. So basically, as we already know that we can apply these artificial intelligence based techniques to automate any kind of things which we actually do manually. Uh, like we can have some AI based techniques for processing the image data. We can apply some ML or DL based technique for processing the GIS based data. GIS means geoinformatics systems, such as data that we get from the satellite images or some from remote sensing kind of devices. Uh, Other thing is processing video data. Nowadays, AI-based techniques are also used for processing the real-time video data that is being generated by the users, and moreover, uh, we can also use these AI-based techniques for solving, processing the text-based data. So, as the FDP is all about that generative AI, so nowadays AI is not only used for just clustering or classification of the data, rather it is used for generating the new data, whether it is text data that you are doing with the Chat GTP and other applications, and it is also used for generating image-based data. Uh, Video-based data is also being generated by the AI-based techniques nowadays. So basically, if we talk about the artificial intelligence or machine learning or deep learning, so basically, as you can say, it's a bigger umbrella on the top of the machine learning or deep learning. Uh, so ML and DL based techniques is used to solve the AI based problems, uh, along with some other techniques. So we can do it for the prediction purposes, such as house price prediction or rainfall prediction or anything that we want to predict. Moreover, we can use it for the classification purpose, uh, like classifying whether the text is generated is it is being generated by the AI, or it is the original text which is being generated manually, or the text or the image is deep fake, or it is original being captured by some of the camera, uh, or for the other kind of classification. Third thing is we can also do some kind of object detection and monitoring. For example, surveillance kind of things, which is being done by the police, might be possible some other kind of surveillance using the video data, object detection such as detecting any kind of object, whether it is a cat, dog, human face, or some weapon, or anything that we can detect. Moreover, clustering and segmentation. I think in the basics of machine learning, we have already gone through. We can have some grouping of some data which is not being labeled, that is called clustering, and we can have image segmentation for detecting the objects. And the ultimate one, that is the data generation, which is being quite popular nowadays using the generative AI. Now, we'll let us discuss some of the popular applications of the AI nowadays, which we can just explore for making our research problems, for exploring some future research ideas. So I will be discussing some of the broad applications, such as where we can use AI in smart agricultures for automating the task, where we can have use of AI to process satellite-based data for the military applications, for the defense applications, for the agriculture-based applications, and many more. Also, we will discuss some of the generative AI-based applications, as well as some of the text-based applications. Now, let us see how we can use AI in agriculture. Moreover, if you have any idea coming in your mind, you can also just unmute and discuss that, whether we can solve this using the machine learning or deep learning, or what kind of requirements that we'll be needing to solve such kind of problems, if any idea is coming to your mind. Some of the I will start from the very basic applications, and then I will go to some of the advanced applications where we can have the use of machine learning and deep learning and AI. So one of the very basic applications that is quite popular, leaf disease detection. So for example, you have some crops and you want to have some kind of applications where you want to assist the farmers, that you can just scan using your mobile phone that which kind of disease your crop is suffering from, and based on the type and severity of the disease, you can recommend some kind of pesticide or some kind of fertilizer or some kind of remedy solutions to farmer, because every farmer is not the expert of every kind of diseases. So what the advantage of making or automating the task of disease detection using the AI-based method is that we can detect such kind of diseases in the very early phase. So generally, farmers gives attention to the crop when there is a lot of deterioration or a lot of loss. Then we generally utilize. But if we have such kind of mounted camera, or we can just do it using the satellite images, using the data such as NDVI index and other kind of methods. So we can just detect the losses or the harms in a very early, and we can just protect it from deteriorating the entire crop. And the idea is that we have, if you have already gone through such kind of applications using deep learning, so deep learning nowadays have such kind of capability that it have even more. It can visualize things which cannot be even visualized by the human naked eye, because in the case of deep learning, we are going to process the image data pixel by pixel. So generally, it can identify or it can detect such kind of things which cannot be even identified by the human naked eye. So this is the power of the deep learning and artificial intelligence nowadays. So that can really help us in solving a lot of real world problems. So for example, if I want to have a automated system which can be used to detect the type of the disease on any crop, so no doubt there are a number of models, but as taught in the first session, there is a theorem that is called freelance theorem. So we don't have generally a particular model which can be used for detection of the diseases, detection of the leaf diseases in all kind of crops. So what you can do, you can choose your specific area of your locality. You can choose your specific crop of your locality. For example, someone is belonging from the Himachal Pradesh. and there is a lot of apple farming is there, or someone is belonging from the Srinagar, there is a lot of kesar farming is there. So we can have collection of the data. We can just capture some images, we can just label those images using the experts from their domain, and we can train our model to just detect those diseases. So for example, this is one of the samples that I'm showing you. For example, this is some healthy image, and this is the diseased image. So you can just fed your model that these are the healthy images. This will be kind of supervised learning, where you have, for example, 1,000 images and 1,000 diseased images. You can just give the labels to your model. Model is going to just process the pixels of these images, process these images, and train itself that what are the possible reasons because of which this leaf is labeled as the diseased image. So based on that training, it can predict in future if you'll give you if you'll provide some unseen data, and it is going to just predict that this particular leaf or this particular image is diseased or not the diseased one. So similarly, so this is the binary classification where you can just have healthy or unhealthy disease. Similarly, we can have multi-class classification where you can have prediction of diseases such as this is early blight and this is late blight. So this is called multi-class classification. You can also give your model the category of diseases, that this is early blight, this is late blight, and this is such kind of diseases. This is your model is going to train, and your model is going to predict in future. So similarly, this is the case of tomato where we have the four class of diseases. So one of the why this application is so popular, because you can have your own data. You can choose the crop of your locality. You can choose the diseases which have not been explored for the detection of the diseases. Moreover, one of the other application of the AI or deep learning for the uh, smart agriculture is that crop growth monitoring. For example, you can also do crop growth monitoring. How we can do this? We can just have some camera installed on a land, and it is going to capture images on some time period basis. For example, I'm capturing images today, and I might be possible I'm capturing some images after 5 days, after 10 days, after 15 days, and after 20 days. So we can uh, just analyze and investigate the canopy of the crop. We can just analyze the increment in the height of the crop that we are going, and what is the expected, and what actually growth of our crop is nowadays. So what you can do, might be possible you are in Gurgaon and you have your land in the Srinagar, or you have in your land in the Kerala. You can have such kind of camera mounted or your land, and you can just using the cloud, using the deep learning based method, you can just automate the task, and deep learning models are going to automatically inform you periodically that whether your crop is properly growing or not. So we can do crop growth monitoring. What else you can do? You can also perform crop yield detection using the satellite images. For example, if you want to uh, detection, or one of the more popular application is that you can have crop area detection. Crop area detection. So for example, if you want to have your PhD problem, that I am belonging from the Uttar Pradesh, and I want to know that what is going to be the yield of sugarcane in the next year. So what we can do, we can just find the area of the sugarcane in the entire UP region using the satellite images. This is the power of the AI and deep learning nowadays. We can have the images from the Sentinel-2 or some of the other satellites which are providing the data at free of cost. There are some of the websites, and we can just segment that this is the area where the crop is of sugarcane or of wheat or of some other kind of things. So no doubt I will also show you some of the applications using the satellite and GIS based data, where you will be able to visualize the things, and a lot of thoughts will come in your mind that yes, this is the thing that we can do, and we can have some novel research based problems that can be solved using the machine learning and deep learning kind of things. So moving ahead, uh, this is the kind of not only the classification, you can also do some kind of segmentation here. Like you can just also segment this area, that yeah, this is the area which is being infected, and so on the basis of that, you can also just find the severity of the disease in that particular crop, that how severe that disease is in my crop. And on the basis of that, what you can do, you can also make a pesticide recommendation system, that if your crop is very much deteriorated, and the intensity and the severity of the disease is high, so in that case you can just recommend the quantity of the pesticide that can be used by the farmers. So also this is one of the novel area that has been not much explored, that you can, in the field of smart agriculture, that you can do. And moreover, there are a number of techniques that you can use. For example, this is the cauliflower. So I have just collected this data from some field, uh, that this is the images of the cauliflower. And if you want to detect that this cauliflower is fresh or not, you can just use some AI based methods. So just see, we have also nowadays explainable AI, which is going to show you the area or the reason because of which your model is saying that this is not the fresh cauliflower, this is the diseased one, or this is the not diseased one. For example, just see, there are some techniques such as, might be possible you have heard techniques like GradCam, Lime, and other things, which will tell you not only the class belongingness, also explain you that why this particular image or this particular data sample is being classified to the class which is really not which is really disease or fresh one. For example, you can just see, so this is the black region, and because of this is actually, this cauliflower is not fresh one. So this model is just giving this kind of heat map. Yeah, this is the reason. Because of this reason, I am saying that this is not the first one. So for example, this is the leaf. So in this area is basically infected, and this is basically suffering from some disease. So your model is giving the heat map. Yeah, this red region is giving you the reason of interest, that why I am saying that this particular crop or this particular leaf is not the fresh one, or or the diseased one. So there are multiple things or multiple areas that you can just explore and do such kind of hands-on and make your possible research problem. This is also one of the problem that we have explored few days back. We have just collected the data of the eggplant, and try to automate the task that whether that particular eggplant is basically diseased or some is healthy one. So these are the type of the disease. So this one is the healthy, and this one is suffering with this disease. This one is suffering with this disease. This one is suffering from this disease, and this one is suffering from this disease. So one of the possible, one of the major advantage of this is that you can have your own data. You can have your own crop. You can have your own fruit, because every crop or fruit or or vegetable or leaf have different kind of problem. No model, there is no model which can give the efficient result on every type of crop. So if you are exploring some new crop, you are telling the challenges, that these are the challenges which cannot be explored by the existing model. Naturally, you can have such kind of novelty, that yes, I am making the model which is lightweight, which have such kind of strengths, which can really be used for the problem solving, and for solving such kind of problems that is novel, when which is being not explored by the previous models. Yes, this is the advantage, and that's why I am taking some of the problems that we have that are not benchmarked yet. We have just collected the data and we have solved those problems for the possible outcomes. So there are two applications that I will tell you at this moment. One application is that is the image classification that can be used to classify that uh, this particular image is healthy or this is suffering from some of the disorders or some of the diseases. So one of the basic problem with getting the data, if you are capturing the data for some of the new problem, so one of the basic problems is that sometimes our data is not balanced one. Not only the sometimes, generally the data is not balanced. For example, if you are making the data for the disease detection, so generally what will happen, you have more data samples for the healthy classes. However, you will have less data generally for the diseased classes, because it is not always that your crop is being infected. So you have to visit the land again and again. You have to see the growth of, or the basically health of your crop. And if your crop is being infected, then you will get only the infected images. And not only this, for example, if we have 1, 2, 3 and 4, if I have 4 types of diseases, so it is not always necessary that you will get equal amount of images or sufficient amount of images for all the types of diseases. So might be possible you are getting this type of disease, but you are not getting this type of disease at this particular season. Or might be possible you are not getting this type of disease for a particular season. So what we can do that we can apply some image augmentation techniques in order to make your data balanced. So for example, if you have the 1000 images of the healthy class, आपके पास 1000 images healthy class की हैं, but if you have only 200 images of disease 1, and if you have only 250 images of disease 2, and only 150 images of disease type 3. So you have 4 classes: class C1, class C2, class C3, class C4. However, C4 is minority one because it have only 150 images. So your results are going to be biased for the healthy images, because they have more data samples. Your model is going to learn more and more feature maps from those class which have more number of images, and your model is going to learn less feature maps for the classes which is having less number of image samples. That is called minority class. So in that case, what solution you have? One is the basically traditional augmentation method. So we have such kind of augmentation method where you can, if you want to increase the number of samples, you can have image translation. You can just rotate the images. You can just scale it. So all type of image augmentations are visually which you can visualize here, and you can do some kind of contrast adjustment. You can just blur it. So हमारे पास image samples को बढ़ाने के there are two kind of things. One is the traditional thing that we were using conventionally, that just rotate images, flip images, just add some noise to the images, just blur those images. And by doing such kind of things, you can just increase the number of image samples, and especially for the minority classes. अगर जो आपके पास यहाँ 150 images हैं, what you can do, हमने कुछ rotate कर दी, कुछ blur कर दी, कुछ contrast बढ़ा दिया, कुछ noise बढ़ा दिया, and by doing such kind of things, we have just upsampled that class so that it should not suffer with the issue of minority class belongingness. However, the problem with this one is that इसके साथ क्या problem है? आपने इमेज रोटेट तो कर दी, यहाँ पे इसको यहाँ से हॉरिजॉन्टल से वर्टिकल कर दिया, एंड दिस एंड दैट स्केल कर दिया, डाउन स्केल कर दिया, बट यहाँ पे फीचर्स नहीं चेंज होंगे. फीचर मैप्स आर नॉट गोइंग टू बी चेंज्ड मच. जो आपका एरिया ऑफ इंटरेस्ट था, दिस इज द रीजन, ये मैं जो इसको सर्किल कर रहा हूँ, दिस इज द रीजन बिकॉज ऑफ विच योर मॉडल वाज ट्रेनिंग इटसेल्फ कि इसमें ये वाली डिजीज हो सकती है, बट डूइंग सच काइंड ऑफ रोटेशंस और ऑगमेंटेशंस, योर फीचर मैप इज नॉट गोइंग टू बी चेंज्ड. वो तो नहीं बदलेगा. And because of that, might be possible your model is not robust enough to detect that particular disease. So this is the problem with such kind of traditional data augmentation techniques. So now, what is the possible application of AI that we can apply here to resolve, to remedy the issue of minority classes? So one is the basically generative AI is techniques that is called GAN-based model, generative adversarial networks. No doubt, technically, we will discuss about the GANs in much detail about the mathematical foundations and working of the GAN models in the tomorrow session. But at this moment, might be possible you are already aware. But if you are not aware, so basically GAN models are basically used to generate the duplicate images. So, for example, you have seen a lot of fake images or deepfake images on the social media, like fake images of the Rahul Gandhi or Modi or some popular cricketers or popular celebrities. So those images are being generated, and which looks very realistic. Even sometimes you'll not be able to just identify that whether this image is fake or real. So what we can do, we can have a very positive application here in the case of solving the issue of minority classes. That application is use of GAN models to upsample the data. So for example, for this particular disease, I have only or for this particular class images, I have only 150 images, and what I need to do, I need to increase the sample size so that this class should not suffer with the minority issue. Or for example, I have 1500 images, but I want to make it 3000, I want to make it 4000 to make our model more robust so that it can classify the image data correctly. So what we can do, we can just apply some GAN-based models to generate images of any kind, and such that we have sufficient number of images to train our model for the proper classification. यहाँ पे आप देखो, हमने विजुलाइज करके दिखाया आपको कि हाउ GAN वर्क्स. इट इज गोइंग टू जनरेट द इमेजेस. 100 इपोक ट्रेनिंग किया तो ऐसी इमेज जनरेट हुई, 200 इपोक जनरेट किया तो ऐसी इमेज जनरेट हुई थी, 300 इपोक जनरेट किया तो ऐसी, 400, 500, 1000, 2000 we can have such kind of images. और उसके बाद हमने इसको क्या किया, SR GAN is a kind of GAN जिसको हम लोग बाद में डिस्कस करेंगे. This is called a super resolution GAN. So if you want to increase the resolution of the GAN, if you want to increase the resolution of some particular image which is blurred one, which is not that clear. So for example, जैसे अभी हमारी डिफेंस एप्लीकेशन ने क्या किया था, whatever destruction we have made in Pakistan, we have shown them using the to our people using the satellite images. If the images were blurred one, we can just apply some kind of SR super resolution GAN method. It is going to reconstruct that image with the same features and with a better visibility. So this is a very popular application of the generative AI, that if you want to increase the resolution or clarity of the image, you can just apply the generative AI model such as SR GAN, that's called as super resolution GAN, which can just enhance the quality of the image. And moreover, you can just use any traditional or conventional GAN model to upsample your images, that we have done in case of this eggplant disease. Now coming to one of the very popular application, that is called use of AI for environment monitoring using the remote sensing. So here I am going to discuss two kind of data. One is the data which is being captured using the drone. Drone से data हम what we can do, or we can use unmanned aerial vehicle data, जो बहुत आजकल यूज होता है, which is very popular nowadays, and moreover even in the military applications as well. So sometimes we used to throw some unmanned aerial vehicle to the enemy's territory to just capture the information, to capture some of the images and data that can be processed to get some meaningful information. So a lot of applications are there. So it is being surveillance using the drone is being used for the crowd monitoring in applications such as Kumbh or some rallies by some of the popular leaders such as Modi and Rahul Gandhi and leaders of the national importance. So we have a lot of applications using the drone and UV data, and moreover, the second thing is that we can have satellite data. हम लोग satellite data को use करके we can have multiple of applications that has not been explored yet. बहुत सारी ऐसी applications हैं जो हम लोग explore कर सकते हैं. We can think of that these are the novel applications that are yet unexplored. We can just explore, we can just solve using the artificial intelligence based methods. अभी आप देखेंगे आपको खुद से समझ में आएगा. Let us see. So this is one of the popular application. We have done this work last year. These images are basically captured from the drone. For example, you want to solve this problem. So generally what we do, we used to litter a lot of waste material. हमने कोल्ड ड्रिंक पिया, कहीं पार्क में फेंक दिया या रोड पे फेंक दिया, पॉलिथीन्स फेंक दिया, टॉय को फेंक दिया. So there is a lot of waste items which is thrown in the public places in the India. So what we can do, we can have such kind of surveillance using the satellite or using drone to check that whether this particular city, whether this particular park or whether this particular area is clean or not. We can just automate this task using the AI-based methods. So ये हमने आपको waste के लिए बताया. This can be any object, not only the waste. So if you want to test how much amount of greenery is there, if you want to test कि यहाँ पे poly bags का use होता है या फिर नहीं होता है, if you want to test यहाँ पे नाला बह रहा है या फिर नहीं बह रहा है, we can have any kind of object that we can train our model, train our system, and we can just deploy that particular system on some particular unmanned aerial vehicle, on some drone, and we can just monitor that area to do such kind of surveillance कि यहाँ पे पब्लिक लिटरिंग है या नहीं है, यहाँ पे नाले बह रहे हैं या फिर नहीं है, यमुना की सफाई हो रही है या फिर नहीं हो रही है. वी कैन डू दैट जॉब remotely using the satellite data, using the drone data. तो यहाँ पे आप देखेंगे कि if you are capturing the object from remotely, ऑब्जेक्ट्स आपको बहुत क्लीन नहीं दिखेंगे. ये देखो आपको एक टीम का पैच है, बट यहाँ पे आपने डायरेक्ट उसको मैनुअली कैप्चर किया होता तो ये ऑब्जेक्ट क्लियर दिखता, बट इट इज बीइंग रिमोटली सेंस्ड. दिस इज द रीजन जो ऑब्जेक्ट्स आपको बहुत माइनर साइज के दिख रहे हैं. ये बॉटल्स है, ये जस्ट आई एम इनसर्कलिंग द ऑब्जेक्ट. यू कैन जस्ट सी दिस इज द चैलेंज, एंड whenever we have some challenge, we have some opportunity to solve it, to make the problem researchable, to make the problem novel. तो जहां जहां पे challenges हैं, वहां पे naturally we have the opportunities. And the important thing is that if you are capturing such kind of data to train a model, the important thing is that you can have the novel data which is not requiring the labeling from the expert. अगर जो मैं कह रहा हूँ कि आपको medical data पे काम करना है, then you cannot capture the data. You have to tie up with the hospitals. You need the legal consent from the customers, from patients, and only doctors can label that data. But if I'm talking about labeling the public littering, ये bottle है या फिर ये plastic है या फिर ये polythene है, then nobody is going to question you that कि ये आपने labeling सही किया नहीं की, because everybody knows that, everybody is expert of that कि waste की यहाँ पे bottle है, plastic है या फिर whatever the waste item is that. And the challenge is that it is being remotely sensed. ये remote से sense किया गया है, वो objects बहुत छोटे दिखते हैं. So you need a special model. Although there are a lot of models such as YOLO is a popular model which is used for the object detection. But अगर जो आप special cases हैं, and not only this, for example, if you are if you need some urgent surveillance in the rainy season, or if you need some urgent surveillance in the cloudy season, hazy season, अगर जो आपने देखा बहुत सारा fog है या बहुत सारा pollution है, या in the winter season there is a lot of fog is there, and in the case of fog you have a lot of noise in the data. वहां पे आपके ट्रेडिशनल एंड कन्वेंशनल मॉडल्स काम नहीं करेंगे, then you have a new research problem, that detecting the objects in the extreme weather conditions, such as in the hazy conditions, is in the foggy conditions, in the rainy conditions, in the remotely sensed conditions. You have a lot of novel problems that you can just explore, and you can collect the data, you can train your models. We will also discuss in detail how we can use the GAN and diffusion based model to dehaze the data. अगर हमने कोई डेटा कैप्चर किया है, वो फॉगी सिचुएशन में कैप्चर किया, उसमें बहुत सारे नॉइज है, आपका मॉडल क्लासीफाई नहीं कर पाएगा उसको, क्योंकि उसमें नॉइज ही मैक्सिमम है. Then we have such kind of models such as diffusion or SR GANs, which can be used to just denoise it, to just create the images, which will remove that complex background, complex environment, and give you the crystal clear image that can be used for clustering and classification kind of purposes. तो आपके पास बहुत सारी चीजें हैं सोचने को, करने को. This is the reason I am just giving you some visual samples that look, see, and think of that what you can do, what novel you can think, and where you can or where you will be apply such kind of models. And in the upcoming sessions, you can also have such kind of thinking, and you can just ask with your experts that can I apply such kind of model for solving such kind of problems that you can think of. तो यहाँ पे ऑब्जेक्ट सेगमेंटेशन किया गया है, एंड दिस इज द एक्चुअल मास्क ऑफ द डेटा. ये एक्चुअल मास्क है, ये जो आपको बता रहा है कि यहाँ पे कोई ऑब्जेक्ट है, एंड बेसिकली वी आर एबल टू सी दैट we can just apply some kind of deep learning based method which are going to predict, which are going to segment. ये segment करके आपको बता देंगे कि यहाँ पे littering है, and you can also quantify that what is the percentage of littering, what is the severity of that public littering for detecting the waste. So this is the one area that you can think of. Now, coming to the point in the last session that might be possible you have gone through, otherwise in the future sessions we'll go through a lot of layers in the deep learning model, that this is the convolution layer, this is softmax layer, this is this one layer, and this is that one layer. So I will recommend you that whenever you are doing some kind of hands-on, जब भी आप hands-on करते हैं, or whenever you are just practicing some kind of deep learning models for solving some AI-based problems, just try to visualize the outcome of each and every layer. Try to visualize theoretically and try to visualize practically by applying each and every layer, that yeah, this is the input, and after that, after applying this layer, then what should be the output, what output is coming to your mind, and what output your layer is giving. तब जाके आप visualize कर पाओगे. You will sense, you will be able to sense in future कि यहाँ पे ये वाली लेयर लगा देने से, या अटेंशन लगाने से, या फिर कन्वोल्यूशन लगाने से मुझे क्या बेनिफिट मिलेगा, एंड क्या बेनिफिट नहीं मिलेगा. यहाँ पे आप देखो, ये हमने आपको विजुअलाइज करके एक एग्जांपल बना के दिखाया है, सो दैट यू कैन जस्ट सी कि मैं क्या करूंगा, उसका इमेज पे मेरी क्या इफेक्ट पड़ेगा, सो दैट यू कैन जस्ट विजुअलाइज कि मुझे क्या करना चाहिए और क्या नहीं करना चाहिए. देखो, जैसे यहाँ पे मेरे पास क्या है, आई हैव दिस काइंड ऑफ इमेज. मेरे पास ये इमेज थी, सेम इमेज है. यहाँ पे बहुत जो माइन्यूट से दिख रहे हैं, ये क्या है, आपके लिटर्ड ऑब्जेक्ट है, लिटर्ड. ये मेरे पास इनपुट इमेज है. तो आप देखो यहाँ पे, नो डाउट आपको बहुत डिटेल में नहीं पता होगा, आई एम नॉट गोइंग मच मैथमेटिकली, बट इन फ्यूचर you can come by looking at this image in the upcoming sessions, so that you can just visualize कि किस लेयर का क्या इफेक्ट पड़ता है. इनकोडर लगाया, क्या हुआ, ऐसा दिख रहा है. सॉल्यूशन 5x5 लगाया, ये इमेज ऐसी कन्वर्ट हो गई. ये दिस इज नॉट थ्योरेटिकल वन, ये प्रैक्टिकली इंप्लीमेंट करके, सैंपल करके इमेज बनाई गई है, सो दैट यू कैन जस्ट विजुअलाइज. यहाँ पे 3x3 कन्वोल्यूशन लगाया, अब क्या आ रहा है, क्यों आ रहा है, ये आप विजुअलाइज कर पाओगे इन द अपकमिंग सेशन. तो यहाँ पे मुझे ऐसा दिख रहा है. आई एम जस्ट शोइंग यू सो दैट यू कैन जस्ट डू सम काइंड ऑफ हैंड्स ऑन लाइक दिस. इसके बाद हमने ये लगाया तो ये हुआ, इसके बाद हमने अटेंशन लगाया तो ये हुआ, उसके बाद फिर हमने स्किप कनेक्शंस लगाया, मैक्स लेयर लगाई तो क्या हो रहा है, हमने बाद अटेंशन बेस्ड फ्यूजन किया तो क्या हो रहा है, फिर मैंने ये ब्लॉक लगाया तो क्या हो रहा है, फिर डाउन सैम्पलिंग इमेज कैसे कैसे छोटे छोटे पैचेस में फिर से हो रही है, डाउन सैम्पल हो रही है, छोटी हो रही है. डाउन सैम्पलिंग करके मैं मेरे जो मेन प्रोमिनेंट फीचर्स हैं उनको मैं क्या कर पा रहा हूँ, ट्रैक कर पा रहा हूँ, उनको कैप्चर कर पा रहा हूँ. तो यहाँ जो मैंने डाउन सैंपल किया है, यहाँ पे देखो जो मेन आपका ऑब्जेक्ट था, ये वही ऑब्जेक्ट कैप्चर होके आ गया है. मेरा एरिया ऑफ इंटरेस्ट यही था, बिकॉज आई वांट टू परफॉर्म सम काइंड ऑफ अटेंशन. तो यहाँ पे आप देखोगे, देयर इज अ मॉडल, देयर इज पॉपुलर मॉडल फॉर द सेगमेंटेशन, दैट इज कॉल्ड यूनिट मॉडल. वो नीचे से ऊपर की तरफ चलता है, यू शेप एक बनाता है. एक बार डाउन सैंपल करता जाएगा, मेन ऑब्जेक्ट डिटेक्ट कर लेगा, उसके बाद अप सैंपल करते हुए मेन आपको प्रॉपर इमेज बना देगा विद बैकग्राउंड एंड ऑल द इन्फॉर्मेशन दैट वी हैव। अब आप देखिए यहाँ पे कि फिर से मैंने अपना जो ऑब्जेक्ट इंटरेस्ट था उसको पकड़ा और पकड़ के वापस से इसको अप सैंपल करते हुए मैं अपनी ओरिजिनल इमेज की तरफ बढ़ रहा हूँ। और ये मेरा क्या है, दिस इज द फाइनल इमेज दैट आई एम गेटिंग, which is giving you the segmented portion, yeah, that this portion have such kind of objects that you can use. So this is one of the example. You can do it for example, you are doing as a professor in some institute and you want that कि मेरे कॉलेज में कोई बच्चा ऐसा ना है जिसके पास गन है, और दिस इज द सम सेंसिटिव एरिया। मेरे कॉलेज में कोई ऐसा बच्चा ना है जो कैप लगा के आना चाहता है, मेरे कॉलेज में कोई ऐसा एंटर ना करे विच इज हैविंग सच काइंड ऑफ सस्पिशियस थिंग्स। यू कैन डू सम काइंड ऑफ ऑब्जेक्ट डिटेक्शन। और फॉर एग्जांपल आपने कॉलेज के बाहर एक कैमरा माउंट किया एंड यू वांट टू डिटेक्ट दैट कि if someone is two persons are fighting with some weapon, or if two students are fighting, then we can detect and we can put some alarm. Then you can use some deep learning based models to just deep learning based model to detect those objects and solve some kind of real kind of application. Yeah, this is also one of the possible application. And for example, you want to monitor some kind of rivers, that what is the uh, change in beds of the river, and what is the amount of built up area around the territory of the rivers. You can apply such kind of you can just apply some deep learning based model, uh, which can be trained and which can be applied to solve the problems. Let us see. So for example, this is the one of the original image. This data is basically captured from the Himachal Pradesh, and this data belongs to the Himalayan region of the Himachal. And you can see that what we are doing, we are basically trying to segment that what is the built area, and what is the green area, and what is the water based area in that particular area. So this kind of work can be used for detecting the change in the demography, to detect the how that particular region is being changing over the course of time. So for example, if I have captured the data from year 2000, and after that I have captured some data in 2005, then I have captured the data in 2010, and then I have captured the data in 2015, basically in the time intervals of 5 years. What we can do, this is a very very important application that we can have. We can just check what is the percentage change in the demography of that particular area. For example, we can check that how much built up area is increasing, how much greenery or forest area is decreasing, how much vegetation is increasing, how the original hills or original lakes are being changed, are being deteriorated uh, by the urbanization, or by the mining, or by some other kind of reasons. So for example, if we study about the Aravalli hills of the Rajasthan, what we can analyze that from last 15 years, if we observe using the satellite data, that from last 15 years there is 30 to 40% deterioration in the Aravalli hills by the illegal minings. How we can do? We can just have some deep learning based models which can be trained on the data that we have acquired, and those models are going to forecast that what are the things that may happen in the future, that might be possible after 20 or 20, 30 or 50 or 100 years. Aravali Hills may be completely deteriorated. So we can have some kind of social issues that can be solved using the deep learning and AI based things. And the reason is that why these things are nowadays catching the attention, because now we have much and much computational powers in the form of GPUs that can be used to unfold the problems, because traditionally we don't have such computational systems available with us which can process those huge data. Because this satellite data is very huge in nature, we need a lot of computational power to just process the data. Just see in the images that this is the water region, and our model is just predicting, yeah, this is the water region, and this is the green region, and this gray is the built-up area. Just investigate that over the course of time, how this built area is changing, how this greenery is reducing in some particular territory. What you can just choose the area from your region, and you just applies. You just have some data with you. You can just train your model, and you can just get some useful findings. Yeah, you can also do. I'm exploring different kind of problems using different kind of data, so that you can just think of. For example, uh, you can just analyze and investigate that how the river beds are changing. Is there any change in the river beds or not? So we can have such kind of images. For example, this image belongs to the Yamuna Delhi region. So we can just segment it. We can perform some kind of pixel-wise segmentation to get how the beds of this Yamuna is changing in the Delhi. So one of the very popular application that you can do, how any natural resource, any lake, any river, any hilly station region, or any particular region is being deteriorated by the course of time, and you can just solve that issue to catch the attention of the concerned concerned authorities. Coming to some more GIS based applications which are quite easy to solve nowadays, because nowadays Google Earth Engine is also providing a lot of facilities to get the data, to cluster the data. So you can use that for solving such kind of problem. One of the basic problem is that I am basically uh, you can just, for example, you can just track how much is the wetland in a particular state or in a particular district. So if I talk about the Rajasthan, you can just map that what is the percentage of wetland in the Rajasthan right now, what was it in the 5 year back, what was in the 10 year back. And moreover, if you want to do for surface water mapping, you can also do some kind of precipitation time series analysis. You can also do it for land use and land cover classification. You can also perform flood mapping. So every year we have a problem of floods. You can use satellite data to map that these are the potential areas. These are the potential areas where we have a problem of flood. You can use the remote sensing data. You can use the unmanned aerial vehicle data. You can use the satellite data. Just map that these are the area where there is a continuous problem of flood in each year, and you can just make a report using the AI-based methods to give the concerned authorities that these are the areas, potential areas, and potential problems that can be explored, that can be solved in future. Also, you can do some kind of drought monitoring, because government does a lot of gives a lot of schemes for the drought affected areas, for the flood affected areas. And nowadays what we do manual monitoring by the concerned authorities, uh, uh, that just go and make a survey that what are the areas where we have a problem of drought this year or a problem of flood this year. So there are a lot of chances that might be possible. There may be some biasness in the manual data collection. So what we can do, we can just use remote sensing based applications using drones, using satellite images to collect the data and to analyze that whether this particular region is suffering from flood, drought, or not. For example, I'm taking this area. I'm taking this area of Jaipur, and I want to know that what is the wetland in the Jaipur, what is the percentage of wetland in the Jaipur. What we can see, we already know that this is Jal Mahal, and this is the water. This lake, this is a lake, this is the water here in the Jaipur, and also this is some lake, and this is called as Kannaught Dam in the Jaipur. So what you can clearly visualize that this is the wetland in the Jaipur area. So you can just create some manual mask that this is the wetland, and in future what you may do, you can train your model, and your model is going to automatically detect and automatically sense and automatically monitor in future that for this particular area, this is the wetland, this is the forest area, this is the built up area, and this is the such kind of area like that. So let us see the results. So in this way, your model is basically able to detect, yes, this is able to segment properly, this is the water based area. Not only water, you can have the problem of your interest, where you can use AI or Gen AI to solve such kind of problems. And for such kind of problems, what we need to do, we need to form some step-by-step analysis. In the first step, we have to collect the images of that particular region of interest over a span of time. So, for example, in this case, we have collected the images of from 2024. We have to just make composite database of images, and after that, what you need to do, you need to make the classes of the data, that this is the urban region, this is the water region, and this is this kind of region that we have, and on the basis of that, you can form some kind of analysis. So in case of removing the noise, you can have some kind of data pre-processing. This is one of the methods, that is compute median composite. We can take the median of the data samples in order to remove the noise, because sometimes there is a there are clouds, there are some haze, there are some fog, which are not going to give clear images. So we have such kind of data pre-processing techniques where we can have some mean, median, and averaging kind of values that can be used to remove the outliers from that particular data. So what we can see, we can just map it. These are the reasons. Blue means water. Here we have water, and orange means cropland or field. This is cropland or field, and gray means urban. These are the urban areas. So there are some things which are already being provided by the Google, but there are number of things which are not being provided by the Google or some other giant companies. So for such kind of problems specific to your region, you can have your own data collection, model training, and simulation. So here you can see how beautifully we can just display that classified regions. That blue means that see the water in this particular area. So area might be possible. This is basically Jaipur belt. You can have the area of your territory. These blue points denote that this is the water. This gray points denote this is the built-up area, and this orange point denotes that this is the cropland or freehold land. So if you go outside of the city, we can see that majority of the area is cropland or freehold land. So these are the possible applications that you can have using the machine learning, deep learning, and artificial intelligence. Similarly, what you can do, you can just cluster some of the regions. For example, this gray means urban, blue means water, orange means cropland, and red means mountain. We have created one more class that is called mountain. Here you can see that this is the mountain region. And what is the possible application of this? You can have the data from last 20 years and you can just check whether whether that this particular reason is basically mountain, or whether this particular reason is mountain, or this particular reason is water, or this particular reason is urban or something else. So what we can do, we can just analyze that how this Aravalli Hills, or how any mountain region, or how any natural resource which is being very important for us is being degraded over the course of time, and you can just catch the attention of the audience using the uh, machine learning and deep learning models. This is the rain. You can also do some kind of monthly rainfall prediction. This is also one of the possible applications where you can use satellite data to do some such kind of things that we can do in detail in the future sessions like this. Acha, let us see. So, for example, if I want to check that how greenery in the Rajasthan is being affected by the course of time, whether it is increasing or whether it is decreasing by the course of time, this also you can do using the machine learning or deep learning based task. So let us see. I have just taken this region of the Rajasthan. So these are the states of the Rajasthan, and why what you can do here, you can just have such kind of models. So here, this green belt represent that this is the greenery in the Rajasthan, in the neighboring districts of the Jaipur, and this green pixels basically represent the vegetation, and black represents the non-vegetation. So more the green pixels are, more the intensity of the green pixel is, more the green vegetation index is there, and black means this is non-vegetation. So we can have such kind of smart applications using the machine learning and deep learning. How smart you can perform that, you can just check it out. Yeah, if I see about the Jaisalmer, you already know that uh, Jaisalmer have the least greenery in the Rajasthan, because this is a kind of desert. So you are seeing that this region is looking completely black, which is witnessing that the model is performing quite good, and it is giving the good results to you that this particular region is black, giving that this region is not green one. Okay, now I'm coming to one of the very interesting area of application, that what you can do with the video data uh, using the deep learning based method. What you can do using that video data, there are a lot of opportunities to process the video data and automate the task that can be done manually. And no doubt there are some things which cannot be done manually. The very important application is that if you want to perform video surveillance, so what happens till date that uh, if if any event occurred, so for example from my lab one computer is stolen, so after the occurrence of the event I got to know that this computer is being stolen by someone. And now I used to keep uh, scrolling the cameras, and we used to keep uh, monitoring the video footage using the historical data, that who has stolen that particular computer, but that has gone. You cannot you cannot sit in front of your system all the time to monitor that who is coming in your lab and who is going out of your lab. Or for example, you have installed one camera out of your house, and uh, you are 1,000 kilometers away from your house. You want to know that whether your house is safe or not. So in that case, what you can do, you can have some smart video surveillance using the deep learning methods, where you can train your model that this is the activity that I want to catch, that this is the activity I want to catch. I want to catch. What kind of activity? If someone is coming out of your house, if someone is coming out of your house with some material, with some computer, with bike, with car, or with something, you can put an automatic alarm that yes, if someone is coming with this particular kind of object, then I need a alarm at that time so that I can be attentive and I can catch that particular thief immediately. Not only that, not only this, there are multiple areas of video data processing that will come in your mind after looking at this video. Let us see. So this is one of the project that we have done basically for one of the company called Duma Chain, which is situated in Australia. So what was their requirement? Their requirement was uh, they have their own restaurant, and if someone is coming in their restaurant without washing the hand, because there are a lot of hygiene issues in the kitchen areas. So what they want that all the workers which are entering into the kitchen must enter into the kitchen after washing their hand. This was there. And what we can do, we cannot deploy one person who is going to see all the time that if someone is entering into the kitchen, he should wash his hand first and then enter into the kitchen to cook the food items. So what the problem they have given that I will mount a camera near the wash basin. This is the wash basin, and if someone is uh, coming and washing his hand with the soap, it's okay. And if someone is coming and not washing his hand with the soap, then you must put an alarm which will intimate the concerned authorities. Yeah, that this person has not washed his hand. This is very important use case of the AI. And after looking in this, you can think of number of problems that can be solved using the artificial intelligence. Let us see. So this is really this is not the generated code. This is the model that is performing. This is some model which is based on the YOLO, not exactly the YOLO, but it is modified version of the YOLO, which is doing some kind of object detection and which is basically labeling that this person is performing hand wash or not. Just look at this video. This is really very interesting. Just look at this. This is the kitchen area and some person will just enter. Yeah, she's entering into the kitchen area. Just see, person is coming, pre-rinse fingers. Yeah, he's washing his hand, and my model is detecting that what she is doing. So I have detected the objects like rinsing, like hands, fingers, soap, tap, a dryer. If it is drying her hand, my model is also saying that yeah, she is using dryer. Again, she is rinsing. Again, she is coming in front of the dryer and she has gone away. Look how smartly my model is making surveillance that cannot be done all the time manually. So how we have solved this problem? We have just detected the objects that if some person is coming and using the soap and washing his hand, and my model is able to detect this. So how we have done it? We have just collected the footages. We have converted that footages into the frames, into the images. We have labeled those images that this is the soap, this is the fingers, this is the rinsing process. And if you are able to get the desired result, if some person is washing his hand, we are able to catch that yeah, this person is washing his hands, and so on. See, after looking at this, you can have a number of thoughts that will come to your mind. Yeah, that we can also do such kind of surveillance. For example, for the child safety, majority of the parents who are basically both working parents, putting his child alone or with the help of the maid, is installing camera in his home. But uh, sometimes they used to just watch with his or her mobile phones that what his child is doing. But if you are busy in your meeting, if you are busy in some your official work, then you will not be able to monitor your kid all the time. What we can do, we can have a deep learning model which is going to monitor the activity of the child. So for example, if I want that if my child is performing such kind of any kind of suspicious activity, then I should get an alarm that your child is performing this kind of activity. So for example, if my child have knife in his hand, there must be some alarm that yeah, your child is doing something which is in the red alert. You should catch an immediate attention, call your maid. For example, my child is going out of the in the balcony, and it is he or she is steering in the balcony, so it may be dangerous for you. You may detect it using the deep learning model. If police want to catch the thief, might be possible he may have some data of the criminals. He may train his her model. Police may train a model covering the entire data of the criminals. And in future, if that criminal is doing some crime again, he may install smart cameras on the in the red lights where that criminal can be caught automatically without any manual attention. Let us see the next model of this particular deep learning application. Detection of jewelry before entering the kitchen. This is also one of the possible use case. The client says that I want that if someone is working in the kitchen, he or she should not wear any kind of jewelry. That I don't want that this particular person should wear any kind of jewelry, because that is not hygienic. Might be possible I'm wearing a watch, I'm wearing a bracelet, and I'm cooking food. So the bacteria or the viruses which are in the bracelet, which are in the brinjal, which are in the watch, may infect the food process. So I want that if someone is entering into the kitchen and he is wearing any jewelry, then there must be some alarm that this person is wearing some jewelry or ring, kind of that. So in that case, I may also train the model that these are the objects which will be counted as jewelry, and if some person is wearing the jewelry while entering the kitchen area, then that person must be detected and the alarm must be sent to the concerned authorities that yeah, this is not the thing that you wanted. Just see this footage and check that how our model is able to detect the jewelry items. Just check it. He's coming, he's having a long bracelet with her. Yeah, this is really not good. Pre-range jewelry. Just see this is clearly stating that yeah, this is the jewelry that she is wearing. So our model is able to detect the jewelry, and it is going to put the alarm. I think you are able to see that it is able to detect the jewelry. And now after detecting jewelry, it is going to put an alarm to the management that yeah, she is wearing the jewelry, which might be possible that is not good from the point of hygiene. And management take a proper action for it. So the ultimate reason for showing you such kind of examples and the solution is that you can have now n number of thoughts in your mind that how we can use artificial intelligence, deep learning or machine learning for solving problems which are related to the surveillance. kind of things. I hope you have some interest in that. Moreover, security purposes, we can use AI, for example, face detections, counting the crowd that we have done in the case of Kumbh Mela. So this is a very popular application of the AI that in the Mahakumbh of Prayagraj, what we have done, we have just used AI-based monitoring, where we have just got the reasons that these are the regions where uh, there is extra crowd, and we can just deploy the police or the military accordingly, that these are the areas we have the extra crowd. So we can do such kind of things using the artificial intelligence. So this is the video that I'm not going to show you now because this is already 5:30. Might be possible you are tired enough. So you can just see in future that how concerned authorities have used drone-based monitoring using the artificial intelligence to just make proper automatic surveillance in the Mahakumbh Prayagraj. No doubt, anomalies in the banks. Banks uses basically AI-based method to detect the anomaly that this may be the customer with the potential frauds. In the case of traffic, we can have satellite-based or drone-based or some mounted camera-based images where we can just perform some kind of surveillance for automatic detection of the traffic, and we can have red light timings according to that. We can just set the timings of the satellite accordingly. Similarly, in the case of defense, you can make your own. You can have your own idea to just help the military applications for the surveillance using the drone in the regions such as Naxals, for the anti-Naxal operations. It is very difficult to perform the task manually, so we can help the CRPF persons with the satellite images, with the drone data, with the sensor-based data. That this is the navigation that you can get. You can get the help from the AI-based operations. The strategic planning, in the case of training, we have a number of simulated environments using the AI-based models that can be used to solve problems. So, no doubt, we can also have a number of applications for categorizing the data which is deepfake. Sometimes there are a lot of cyber frauds which are being done by the deepfakes. Someone is going to send you the clone voice of your son, that your son is under arrest with me, and your son will say that, yeah, Papa, just please rescue me, and the voice will be very close to that of your son, and you will just get panic, and you will transfer some amount to the concerned person, and ultimately after some time you'll be able to know that this was not the original voice of your son or daughter, rather it was a cloned voice using the generative AI. So there are a lot of cyber frauds which are also being performed using the artificial intelligence, that you can basically get a remedy of that. So basically detecting that whether this particular image is deepfake or deepfake image or deepfake video, that you can also do using the artificial intelligence based method. So I think in this session you have got a lot of things to think of, that these are the areas where we can think that what AI can do for us, and what are the possible areas of applications where where we can use artificial intelligence based methods to solve some real world problems, from satellite data, from the video data, from the agricultural point of view, from the environment monitoring point of view. You can think of, and from that thinking, in the upcoming sessions you can just have some brainstorming sessions with the experts, that how I can apply AI based method for unfolding such kind of problems. So if you have any doubts or if you have any queries in your mind, I'm open to solve the queries. Otherwise, we'll go with the quiz, and that will be the end of the today's session. Thank you.
So there are a couple of queries in the messages section.
In the chat box?
Yes, sir. Chat.
The question is resources from where we can get some good quality data sets available for the public. So no doubt there are a lot of repositories. Kaggle is one of the most popular repositories, and apart from Kaggle, there is UCI, GitHub, and there are a lot of repositories. You can just Google out that from which kind of data you want to have. So you can get data accordingly. Kaggle is one of the most popular repository and most wide repository for public available data sets, where you can get good quality of data sets. As far as satellite data sets are concerned, you can just have your own data sets that you can get from Sentinel-2 or Landsat satellite. You can also acquire your own data and label it. That I have already discussed. Second query is a deep learning model using remote sensing imagery with auxiliary tabular data and managing city level issues. 450-kilometer area, like and user change ideas, location, this and this and this. Also, is a system with i7, 24 GB RAM and RTX adequate for. Actually, satellite based data is generally very huge because if you are covering such large area, then that data is no doubt will be very bulky. So CPUs are not able to process this, whether it is 24 GB or not. Definitely will be needing GPUs to process satellite-based data, because that data is multispectral, covering a lot of bands information. So yes, the answer is you will be needing GPU for sure. And third is for deep learning model using remote sensing visionary with auxiliary tabular. This is the same. I think he has just copied and pasted for 3 times. You can also have some deep learning model just to remove this duplication in the data. We can also have AI model for solving this problem. Okay, the next question is, sir, for the amazing explanation, everything was explained so clearly and I understood it properly. Thank you. Thank you. Pardon for sending so many times. I was unable to. Acha. Thank you. Thank you. So thank you, all of you. I think I have solved the queries, but still, if you have any, you can just unmute and ask me directly. Otherwise, we can just end up the session. Bank, is there anything else, or you can just I end up the session? Man, can I end this session right now?
Yes, sir.
Okay, thank you.
Thank you.
Bye.